Hello everyone. Today I'll be explaining static equilibrium using a leg extension exercise problem. Hold 1, 2, 3, 4. In this diagram, I labeled all the forces and lever arms for this example. Fj is going to be the force of the knee joint. Fw will be the force of the weight. Fl is the force of the leg. And Fq is the force of the quad tendon. In blue, I have labeled all the lever arms. My axis of rotation is going to be at the knee joint, where Fj is labeled. So from the axis to the insertion of the quad tendon will be 0.05 meters. From the knee joint to about halfway of the leg would be 0.20 meters. I used halfway because that's where most of the mass of the leg would come from. Then from the knee joint to the weight is 0.40 meters. I also want to note that the angle of the quad tendon is 30 degrees. So now I redrew a simplified version or a free body diagram of the exercise. And the question is, how much force does the quad tendon exert to maintain static equilibrium? Here I begin to write out my equation. If it's in static equilibrium, I could say the sum of the torques equals 0. That would be in green. Torque is going to be force times the lever arm. The first one in purple is the force of the leg, which is mass of the leg times gravity, multiplied by the lever arm, 0.2 meters. Then I have the mass of the weight times gravity, which would equal the force of the weight, times the lever arm, which is 0.4 meters. Those are both positive numbers because the force of the leg and the force of the weight would be pulling the leg into a counterclockwise direction. Then the force of the quad tendon will be pulling the leg into a clockwise direction, and that's going to make the number negative. So now I have minus the force of the quad multiplied by the lever arm, which the lever arm here is going to be 0.05 cosine 30 degrees because that angle θ is 30 degrees. 0.05 would be the adjacent, and I'm trying to find the hypotenuse. Then I'm solving for the variable here at the bottom for the force of the quad tendon. We're going to go ahead and neglect the mass of the leg and assume that the leg is weightless. So I'm just going to go ahead and take that out, and now I'm going to solve with my knowns. Here I solve for the force of the quad tendon. I have the mass of the weight, 20 kilograms, multiplied by gravity, 9.8, multiplied by the lever arm of the weight, 0.4 meters. All of that is divided by 0.05 cosine of 30 degrees, which is the lever arm of the quad tendon. The force of the quad tendon equaled 1,810 newtons of the force exerted by the quad tendon. I just wanted to note here at the bottom in orange that 20 kilograms of weight is about 196 newtons. So in this particular equation, the quad tendon needed to exert about 10 times the amount of the actual weight. Hope everyone has a great day and hope all of that made sense.